Okay, so let's talk about these basic terms in waves. Frequency is the number of complete cycles per unit time or per second. The number of complete cycles. So what is a wave cycle? That would be a complete wavelength passing through a point, a complete wavelength. That is to say, from one trough to the next trough, or one crest to the next crest, or you can say one peak to the next peak. That is a complete cycle. So the number of complete cycles that can pass through a point per unit time are referred to as the frequency of a wave, and the SI unit is the hertz. So frequency is also given as 1 over your period. 1 over your period will give you frequency. So that is the formula. You're also supposed to know about the speed of a wave, or the velocity of a wave. Velocity of a wave is equal to the distance traveled in one period over the time, and your time is your period. Okay, and this is given by the wavelength. So the distance traveled in one period is going to be equal to your wavelength over the time of that period. And so this can be written as 1 over t times your lambda there. That looks like an inverted y, and if you simplify there, you can get velocity is equal to your frequency times your wavelength. But let me get into the details when it comes to these terms, frequency and velocity. Let's go into detail and see exactly what this means. You need to make it intuitive. You have to understand it. So let's get into more detail. Okay, so let's look at the period of a wave. Let's see what really happens. So that's a particle that goes up and back to the original position. When that happens, when a wave moves like that, such that it oscillates a particle from a certain position, it began here, all the way up and back to the original position, that is a complete wave cycle. That's a complete wave cycle. Let me show you this in a different animation. So look at this particle going up and it goes down, and check in this case the distance we have covered. So this is the distance that the wave has covered or has moved. At the same time, it has managed to oscillate this particle up and down to the original position. So it means that we have moved one complete wavelength. So every time we make one complete oscillation, we have also moved one complete wave cycle, and this simply means we have moved an entire wavelength. Why is this important? Okay, so let's go back to the concept of period. So the time required for that complete oscillation to take place is what we call the period. So in this example, it took us 6 seconds to move this particle up and down, and it was the same time that was required to move the wave from one crest, in this case, to the next one trough to the next trough. So that was the time that was required to move our complete wavelength there. So the period is the time that we require to have a one complete wave cycle. Okay, so that being said, let's also look at frequency. So what then is frequency? So frequency is 1 over your period. It is the number of complete cycles that pass through a point in 1 second. So we are simply trying to standardize to 1 second. So in 1 second, that is the unit of time that we have, how many wavelengths are going to be able to pass through a point. In 1 second, how many complete wavelengths are going to be able to pass through a point in space. So if you divide, for this one the period was 6 seconds, so we require 6 seconds to move from trough to trough or crest to crest. we require 6 seconds, and in 1 second we can only move 0.167 of that. We only move a fraction of the complete wavelength. We only move a fraction, and the fraction is 0.167 of the complete wavelength. So that is what frequency is telling you. We require 6 seconds to have the whole complete wavelength passing through a point, but in 1 second we only are able to pass through a point 0.167 of that complete wavelength. So that is what frequency means. It's a fraction of what we can pass through a point in 1 second. It's also possible to have a time period of 1 second, in which case your frequency is going to be equal to exactly 1 hertz. That means you can pass a complete wavelength through a point in exactly 1 second. Okay, with this in mind, let's look into, so those are the crests and troughs. Some terms you just need to know so that you can describe these properties of waves. We already looked at this. That's a complete wavelength there, your lambda. You can measure it from trough to trough, or you should avoid that common mistake. That's not a complete wavelength. For longitudinal waves, we have compressions and rarefactions, so you need to measure your wavelength from a compression to the next compression, or from one rarefaction to the next rarefaction. So that gives you your complete wavelength. Remember, this is important for you to be able to calculate your frequency. And we said the frequency here, I'll emphasize on this, it's very important. This is the 1 over your period, and remember, your period is the time required to pass a complete wavelength through a point. So your frequency is 1 over a period, which gives you now the amount of wavelength that you can pass through a point in 1 second. How much of the complete wavelength can you pass through a point in exactly 1 second? So you must be able to measure the wavelength so that you can talk about this. Okay, let's talk about, so we've talked about this, that in 1 full period of repetition, a wave moves exactly 1 wavelength of displacement, and this is always true of any wave. So again, back to the formula, your velocity is going to be equal to your displacement, the distance here traveled by the wave in 1 complete period of repetition, or 1 complete oscillation, over the time, and the time is the period, the time required to have a complete wavelength passing through a point. So displacement over time, and displacement is the wavelength of the time required for that wavelength to pass through a point. And we know that our period is 1 over frequency, and so we can rearrange that formula. We can invert that and remove our division sign here to multiply here by f over 1 when we invert this one. So it becomes your lambda, your wavelength, times your frequency. Let's look at some illustrations of this at play. So if I'm told that my frequency is 1 hertz, so that means I pass through 1 complete wavelength per second, and yet that complete wavelength is 3 meters, then intuitively this means that I will be moving at 3 meters per second. I'll be moving at 3 meters per second, because in every 1 second I'm able to pass 1 complete wavelength, and yet my complete wavelength is 3 meters. So that gives me here my 3 meters per second. This is what we mean by V is equal to your wavelength times your frequency. So after 1 second, 3 meters, which is the complete wavelength, would have passed through a reference point. Okay, so remember here, the number of wavelengths that pass through this line in 1 second is the frequency. Let's look at a different example here. If I'm told that my frequency is 2 hertz, it means I can pass 2 complete wavelengths through a point, and yet my wavelength is 3 meters. So after 1 second, I would have passed how much? 6 meters. So my speed is 6 meters per second. So this is what it means. Let's meet in the next video.